Homer sheet yet. So let me ask you this. Let's kind of build up toward that question. So Angel, I'm not forgetting your question. Let me build up to it. If I told you that there's a line that goes through 0, 2 with slope equal to 4, right? What would the equation of that line be? Yeah, what two things do you need for the equation of a line? There's two things. You need a slope and the y-intercept or any point. What's really cool if I have the y-intercept, and do I have the y-intercept? Yeah, I got the y-intercept, 0, 2. What's really cool about that? Do I have to use y minus y1 equals mx minus y? What's that 2 otherwise known as? What's the y-intercept, but what's the letter? B. I love it. So this is the y-intercept. If I give you the y-intercept, it kicks so much ass because I can use a smaller equation. All I need is the slope, and I tell you the slope directly. Slope is 4, y-intercept is 0, 2. So y equals mx plus b. Y equals, what's in there for m? 4, because m is the slope. X plus b, 2. Okay, so that's the first level. First level always very easy. So what's the next level up? You know, like we don't have to go another level up. So now if I say line going through 1, 2, and 0, negative, what do you want to say? 0, negative 5.
So what was the question? No question. You just made the equation, or are you supposed
Find the equation of the line that.
Oh, okay. So
Because that's what the question is about. There's a question that says find the equation of the line that is parallel to something. So I'm trying to build up to that problem.
Okay.
The hardest level problem you'll see is the one that I have a question about.
Oh, okay.
And now you just plug in the y1 x, y2 minus y1 over x2.
I like it. Because the people that get math easily are the ones that know how to break it into parts. The people that really do poorly at math are the ones that think they're supposed to do the whole damn thing at once, which is insane. Right? So the parts that I definitely say you should break this into is, one part would be finding the slope, because you need the slope. Y equals mx plus b, y minus y1 equals m, x minus, both of them have an m in it. I have got to know the direction I'm going in. So I have to figure out the slope. Secondly, I need a y-intercept or any point. And in this case, which one of those do I have? Y-intercept, cool. So I didn't make this a very difficult problem yet. So check, I got the y-intercept. Right? I know it's a y-intercept because x is 0. Sweet. Don't forget that. How do I find the slope? Wes kind of pointed us in the right direction. Careful. That's squared. Just second y minus first y. Yeah. So what would it be? It'd be like negative 5 minus 2 over 0 minus 1. I love it.
So the y-intercept, there's always the same y-intercept is 0, right?
Exactly. So if I have the point 7, 0, what's special about that point? That is an, I give it away with the end, but 7, 0. What's special about that point? It's also known as a x-intercept, right? Because the y is 0. It's going to be on the x-axis at 7.
It's not going to go up.
Yeah, it's not going to go up or down at all, so it must be on the x-axis. If I have 0, negative 1, that's a y-intercept. It doesn't go left or right. It only goes down 1. It's on the y-axis. That's why to find the x-intercept, I set y equal to 0. I'm forcing it to tell me where it is. To find the y-intercept, I set x equal to 0. I'm forcing it to tell me where it is. They go together, right?
Okay.
It's crazy how math does. So now I just got to piece it. And once I get these two things, I very often call this and this, I don't know, hopefully this isn't confuse people. This is my own little joke. This is the SDT level, same damn thing. You just plug and chug. You pick the right formula and you put what you know in, right? So which one do I want to use? This one or this one.
Wait, did that say or any?
Where are we looking?
Any point.
Or any point, yeah. Because that would be this guy. I could put any point I want to there. What's the only thing I'm allowed to put there? The y-intercept can go there. That's it, right? So if I have the y-intercept, I can obviously use this one. If I don't have the y-intercept, I obviously must use this other one. Because it's got room for something that's not the y-intercept. Right? The mistake I always see people do is they put a number there that has nothing to do with the y-intercept at all. It's just the y piece of some point. That is the y-intercept. That's all it could be. Here I was nice. I gave you the y-intercept. That's awesome. So I don't have to use this one. I can use that one. And I just got to throw the things in the right place. So I think sometimes students don't trust it because they're like, that's not hard enough. That can't be algebra. That's not hard enough. And they ain't nothing saying that it's got to be hard. What goes here?
7.
Yeah, it's the slope. 7. We calculated the slope using that formula that we all know. 7x plus, in this case, it'll be minus 5, right? And there it is. Anybody have a suggestion on how to check myself? Yeah, if I plug a 1 in, what better come out? A 2. You guys with me? This side of the room, I don't see it. If I plug a 1 in, definitely have to get a 2 out. That's what that point means,
For the x.
right? So if I plug a 1 in, what do I get? 7 times 1 is 7 minus 5 is 2. Sweet. And of course, a 0, I'm going to get a negative 5. I kind of forced it that way. That's why I put a negative 5 there, because that's what's got to be there.
So that's the answer. We're just trying to make the equation.
Exactly. That's the answer. Right?
So
Solve it.
if we don't have a 0 in our, if you don't give us a 0, we're not going to do it over this.
Exactly. Then you have to use the other equation. Right? Yep.
The second one.
Yes.
The same as the top one? M?
Here?
Yeah?
Yeah, that's where it came from.
That's what.
In fact, it's really easy to forget, and
Why 2 minus y1?
everybody forgets what I talk about when I talk about this, and I don't blame you because it like just gets to the point. But that makes this equation. If I multiply those up, and the whole thing about what I said, where that equation comes from, do I need a specific point on a line? Between any 2 points, it's going to be the same slope. Or else what does the line do if the slope changes? It turns. It's not allowed to turn. It's going to be straight. So that's why I can make those any, and then I multiply that up and I get another equation of the line.
We can use it that way, and we're gonna get the same answer.
You have to. In fact, let's do it. Let's pretend like we didn't realize we could use this one. I want to show you. If you use the wrong one, it doesn't matter. So I can do y minus y1 equals m. Let's use the same point. What goes here then? Y minus what?
The first one.
y1, so negative 5. Careful.
Negative 5.
Yeah. Y piece, right? Y minus the y piece equals m
7.
times x minus the x piece.
0.
So you get y
Plus 5.
plus 5.
But that was y1, and that was y2, and x2, and y1.
Say again.
I thought the 0 and 5 was x2 and y2.
Again, it doesn't matter. You can use either point you want to for this.
Okay.
The little subscript really just means it's the point from your one point you want to use. Why did you call it? Because for this equation, I had to have a second point and a first point, right? And those I could even turn around, like we talked about. Okay. So what's the one point that I want to use? This one? So exactly. So I put the x piece of it in there. I put the y piece of it in there. And now look what I get. Of course I get the same equation, right? I have to. And I understand on one level you guys are, some of you guys might be kind of impressed that I got the same answer there, even though I started at something that seemed totally unrelated. The rest of you guys are like, who cares? As always, it's a bunch of numbers and letters, who gives a shit. So I understand that too. I understand that you're feeling. But the reason that it comes out the same is, what do I need to know about a line to be able to describe it? I have to know what direction it's going in, and a point to start it off at. Does it matter if the point's the y-intercept or some? No, it doesn't. I don't care. If I start here and I call that point 0 and I go off in that direction, I can still talk about the line that I'm walking on, right? I don't care if I start at the 0, 0 point or the 4, 0 point or 0, 2. I don't care. I just need a point and a direction, and that's a line, isn't it? Give me a point and a direction, I got a line. So what does the equation of a line require me to know? a point, and the direction. That should now totally make sense. That's all I need for a line, both visually and algebraically. It's kind of weird. All right, so here's the next level.
If you plug in 1, 2, you can call it something into the second one.
Yeah, again, if you plug in 1, 2, like if you did it again, y minus the y piece equals m times x minus the x piece. Y minus 2 equals 7x minus 7, right?
Yeah.
Add the 2. Y equals 7x minus 5, same thing. Now one level is kind of cool to put totally different numbers in, they come out the same. But the slope is what connects this and this together. So it can take any xy from that line. It's got to work. The slope is what gets you from here to there. So that's why kind of that number always makes it come out right. Here's the next level. So now if I just give you some 2 points. So find the equation. Well, let me not do that to you guys. There's shorthand for equation. It's EQ with an N up here. So if I ever write that down, it's because I'm getting tired and I don't want to write that much. Right? So I read that as equation. But find the equation of the line through -1, 2, and 4, 4, 7. Let's see how far you can make it. And I'll give you a little head start. What 2 things do you need?
Slope and any point.
Slope and any point. Preferably the y-intercept, because then I can use the y equals mx plus b. Did I give you the y-intercept?
No.
Shit, so which one do you have to use?
Any point.
Okay, so let me see how far you can make it. Really, truly, the only thing you worry about at first is just find the slope. You forget about everything else about the problem. You don't care that eventually there's going to be a line equation. You don't care. Just find the slope. That's all step 1 is. I made this one a little nice, but you know. So who's got the slope?
1.
Cool, because it's going to be 7 minus 2 over 4 minus -1. So that's 5 over 5, 1, 11. Check, you got the slope. Do we have a point? We got an abundance of points, right? So which one do you want to use? It doesn't matter. Some people want to do all positive. Some people like the smaller numbers. Totally up to you because I don't care. You can use either one. So now just plug and chug, right? If you want to, you can label these. It doesn't really matter which one you call 2 or 1 up here. That's the one point you want to use. That's their labels. So y minus... Sorry. Equals m, 1, the slope that we just figured out, times x minus the x piece, 4. So y minus 7 equals x minus 4. Right? The 1 doesn't change anything. Add the 7.
Y alone.
X plus 3. And remind me, how do you check that? When you plug in a -1, what better come out? 2. Sure enough, when you plug a -1 in, -1 plus 3, 2. When you plug a 4 in, 4 plus 3, 7. Just a nice quick check. You can actually check this stuff. Here's a real quick physical, real-life problem using this, real quick. Who in here, anybody cook or just happen to know? Oh, cool, because I love cooking. I love watching Top Chef and all that. Anybody ever see that? Anyway, it's Irish Chef. Anybody know the boiling point of water off the top of your head? All right, we're getting close.
Celsius or Fahrenheit?
That's my point. Yeah, both. 212. I like it. So 212 for Fahrenheit, right? Fahrenheit is 212. Celsius, anybody know? 100. Because Celsius is based on metric system, which makes more sense. Our number system is 10. It's nice to have boiling point. 100 just makes sense. 212, I don't know what that. So that's the boiling point. What about the freezing point? We all should know.
0 is 32.
Fahrenheit is 32. And again, Celsius, metric, it says, what the hell is that shit all about? 0 makes sense. Right? So aren't these 2 points? There are 2 points up here. When the Celsius is 100, what's the Fahrenheit say?
212.
212. That's the point. Remember we did that snow cooling problem, same kind of idea. If I need to make this many, I need this much money. Right? We made a point out of that. What point is this one?
0.
I like it. Celsius, Fahrenheit, 0, 32. What's really nice about that point?
As 0.
It has a 0. So what point is that? That's the
Y-intercept.
y-intercept. I love it. So to find the equation of the line, and real quick, I'm hoping this doesn't freak you guys out. This is not x, y, is it? It's c, f. Is that cool?
Right.
You can see that?
Yeah.
C, f. So c is like x, f is like y. You guys see that? So what am I missing for the equation then? I've got b. All I'm missing is the slope. So how do you find the slope? Like always. Yeah, the slope would be 212 minus 32. In this case, the change in f, the change in my second dude, divided by the change in my first dude. How we doing? Some guys probably already know this equation. You know the equation f equals blah c. We'll see if you guys do it. We'll see if it looks familiar. 180 over 100. The zeros cancel. 2 goes into both. 9 fifths. How we doing? So then it's not really y equals mx plus b. It's really f equals mc plus b, right?
Right.
Now let me stop right there and make sure you guys are cool with that. X and y are totally freaking arbitrary. We weren't there when they had the meeting and say, let's always use X and Y. So if I want to use something that makes more sense with my problem, I'm totally allowed to because they're just stupid letters. And letters can be whatever I want them to be. So who cares what letters I use? So don't let that bother you. What's the m though?
Slope.
Which is
9 fifths.
plus the b? 32. Does that look familiar to anybody? Anybody ever seen that formula before? If not, it's okay.
Yeah.
How many guys grew up somewhere that uses Celsius? Anybody grew up where they use Celsius? So to you, if I said it was 20 degrees Celsius outside,
That's
do
conversion.
you remember, do you still have an innate feel for what that means? No, okay.
That's
been
the
too long.
conversion equation, isn't it?
This is the conversion equation.
Yeah.
So if it's 20 degrees Celsius outside, does that really mean anything to us? When I first hear that number, being an American, we don't use metric because we're silly that way. But I think cold as hell because 20 sounds cold. But what do we get when you plug it in there? Fahrenheit is 9 fifths times Celsius plus 32. 5 goes into 20 4 times. 9 times 4 is 36 plus 32, 68. Not a bad day, right? It's a nice day. It's actually a little hot temperature for later this week, actually. It's going to be really cool out here. That's not cold. That's decent, right? But that formula tells you how to convert from something you're not used to because you didn't grow up into it into something that makes sense to you. So there's a true physical application of what we just did. That's where that equation comes from.
So everywhere else besides basically America uses metric?
Basically, there's one other country, I forget what it was off the top of my head. There's a country in the face of the earth that
Metric
don't use
seems
metric.
more
Yeah, so that's another conversation for
Yeah.
another time, yeah. Okay.
Does the single line do like compound
That's, no, no. That's not a general metric formula. It's a totally just specific temperature formula, yeah. All right, so coming back to this, let me see what you guys think about this. I'm actually going to just let you guys try this. And this is more like what you're asking about. So find the equation of the line parallel to, well, I'll do that one next. Don't worry. 4x minus y equals 9. Going through. See how far you can make it. So make sure we all start on the same step. What 2 things you write down for yourself that you need? Slope and input. Slope and point. Point. Okay, go for it. Six zero, yeah. So that is not the y-intercept. It's the x-intercept. Oh, well, too bad. We'll do the easy part first. We got a point. Check. All right, that's easy. People get all confused about when they give an equation in there, what's the only thing that equation is good for what I need? My line that I want is how related to this? The line that I want is how related to this line? Parallel, right? So the only thing this tells me about my line is what? What do I know about parallel slope? The parallel lines. They have the same slope. So the only thing this guy can tell me is what my slope is. So okay, there you go. Right? I don't care about his y-intercept. I don't give a crap what his y-intercept is. He's just parallel. Do I care where he is? No. He's just parallel to me. Right? So how do I get the slope of this line?
Y equals 4x minus 9.
Yeah. You can, if you want to. Most of you guys might have done this. I don't know. And then divide by -1. So you go y equals 4x minus 9. Personally, I would just switch y equals 4x minus 9. So what's the slope of that one? 4. What I really want you guys, some people solve this for y and they stop. They say, there you go, Jeff, there's an equation of a line. Is it the line that we wanted? No, my line is parallel to this guy and it has to go through this point. That line doesn't go through that point. So this guy's slope is 4. So what's my slope? If I'm parallel to him, what's my slope? 4. Cool. That's my slope. Check. I got a point. I got the slope. That's why I call it the STT. Once I get those 2 things, same damn thing. Plug it in the formula. Right? I don't care where they come from. I plug it in. Just,
So if you're looking for perpendicular, you put...
I love it. If I would have said perpendicular here, his slope is 4. My slope would have been negative 1/4. Same thing. Then you just throw that number in for n. Right? But everybody either takes too much from this guy, they solve for y and they stop. They think that's the answer. No, that's a different line. I don't care.
So they want the equation.
I want the equation of the line that is parallel to that guy. So solving this guy for y is not enough. Solving him for y, I know his slope, so I know my slope. And I know a point that I go through. Now I can throw all that stuff in here. Put it all together in here. So y minus what? 0. The y piece is 0. Equals m 4. X minus the x piece, 6. And then you just clean it up. Of course, it's really nice on the y side. So is that line parallel to this line? Because you can see they have the same slope. Of course they have the same slope because that's what I put in there, right? And does it go through the point 6, 0? 6 times 4 is 24 minus 24 is 0. Sweet. You can always check yourself at the end.
I'm sorry, I missed what you said. Say again?
Nothing.
About checking.
Oh, same as always. You just plug that point in. Right? And again, in this case, you can also check to make sure these two are parallel, and they are. Right. All right. Again, let's do another one. All right, here's the ugliest one you could possibly see. Ready? It's uglier than what you'll see in the homework, but we'll do it together. Yes, ma'am. Exactly. So let's do a perpendicular one.
It's
Negative 6. Yeah, totally opposite. Find the equation of the line that does stuff. That is perpendicular to this line. And has the same x-intercept as this line. Oh, what do you want to say, Jeff? So people freak out because there are two equations up there, and they solve one for y and they circle it like that's the answer. Right? But neither of those equations is my answer. My line is perpendicular to him. So what is that line going to be able to tell me about my line? Since I'm perpendicular to it, what information can I get from him then? Slope. Because perpendicular means negative reciprocal slopes. So the only thing he's good for is the slope. And it has the same x-intercept. The x-intercept is a point. So the only thing he's good for is giving me a point. And those are the two things that I need. Right? You always, whenever you see this, find the equation of the line that does stuff. You immediately write slope, point. If this happens to be the y-intercept, awesome. If not, oh well, you've got to use the uglier one. And you focus your attention. You focus your attention on just the part that deals with both of these. Right? So the part that deals with the slope is that guy. So take a minute and figure out what his slope is. Don't say it out loud if you already did. Hold on. Good. Exactly. The quickest way to figure out the slope is to solve for y. Because then everything falls into place, right? Solve for y, then mx plus b. The m goes right into place. No. Definitely not. Two reasons. Well, actually, one big reason. It's not in the right form. I can't read slope off because it's not in the right form. Because the slope, I was pointing to this whole thing. Yeah. So how do you solve for y? What do you do?
Move the 4x.
So I force it in there so it's in the right place. And then divide by negative 5. So the negatives cancel there, right?
Yeah.
And you get this ugly ass thing here. Do I give a shit about that one?
No.
No, why not? Because the only thing I need from him is his slope. My line is perpendicular. The only thing, bless you, the only thing he can tell me is what my slope is. What's this line's slope?
4 bits.
So what's my slope? Negative, good. 5/4. Negative reciprocal. And that's why on those problems they said at the beginning, it refers back to the idea from section 3.3, you better know your parallel and perpendicular or you can't do these problems, period. You have to know that. If you don't know that the negative reciprocal, how could you do this? So there's a slope, cool, check. What do I still need? I still need a point, right? And this is why this problem is particularly evil. It's because you get so used to having a point given to you. Here, you got to work for it. It has the same x-intercept as that. So, of course, if I knew that guy's what, I would know my what. It's a very strange question, but it has the same x-intercept as him. So if I knew this guy's x-intercept, I have the same one. My line has the same one. That would be the point that I need, right?
How come you flipped it again?
Because it's perpendicular.
Okay.
Parallel has to be exactly the same. Perpendicular, totally opposite. If one's positive, the other one's negative, and it's reciprocal to make it go at a 90-degree angle.
What do, I'm sorry, Jeff, but
Yeah.
about that, the x-intercept, you're saying his x-intercept has to be the same as yours because you're perpendicular.
No. I want, let me ask you this. Let me ask you this. If I draw a line, here's a line, and it's going off forever in both directions, how many lines are there that are perpendicular to this one? Infinite number, right? This one is, right? What about that one? What about that one? What about that one? What about, let me go up in the airplane, that one?
Yeah.
As long as it's at a 90-degree angle, that line, which goes forever, there are an infinite number of answers. I want the one that's perpendicular to him that happens to have the same intersect as that guy. That's why I get one answer.
So here you just saw it, right?
Well, there, how do I get the x-intercept of anything? How do I get the x-intercept of anything? Set y equal to 0. Yes. To get the blank intercept, you set the other letter to 0. Right? That's all. Ever. So how do I get the point? If I have this guy, my point is actually this guy's x-intercept. So set y equal to 0. Divide by 6 equals 2. So 2, 0 is my point. So now I got a slope, I got a point. They were funky as hell to get, but once I get them, I don't care where they came from, I just plug them in. That's why I call it SDT, same damn thing. You just plug it in.
But you could use
Either what?
6x divided by y equals 12 or 4x divided by
Either one to do what? No. My line is only perpendicular to him. So that means it could be anywhere as long as it's perpendicular. But it also has the same x-intercept as that guy. This is where I get my point from. The only point about my line that I know anything about is the x-intercept. Right? This line is only good for my slope. I only know that I'm perpendicular to him. I could have any point then. I don't know what the point is, right? But this one tells me what my point is. Well, now we're there. Now we're ready to plug and shove. We worked our slope by using the perpendicular to that guy, right? Figured out his slope, figured out the negative reciprocal. Bam. What point do I have? Well, shit, it's got to be the same x-intercept, so I've got to figure out his x-intercept. Bam. Now I plug and shove. I don't have it. I don't have enough information for that. In fact, what's the only point I know, period? This one. That's it. That's all I got. Yeah.
Why did it say 0 instead of the y? Why?
To find the x-intercept, what do you
Whenever we
do?
have like this, we just like.
Not like that, no. To find the x-intercept, what do you do?
What if
You set the y equal to 0. To find the y-intercept,
what if you want to say the y?
to find the y-intercept, you set
And we put
x
0
equal to 0.
Oh, so whenever we have one, the other one's going to be 0. And the point.
Exactly. And we know that. You guys know it better than you think. I mean, that's what I was doing earlier. If I wrote this down, is that an x or a y-intercept?
x and y.
Because where would it be? Wouldn't it be up here on the y-axis? And what's true about this is the y-intercept. What's x? In fact, any y-intercept you can imagine, aren't they all going to be 0, comma something? So how do you find a y-intercept? You make x 0. You force it to tell you. I always think about somebody caught somebody, put them under the hot bright light. Tell me, you know. So you can, this is the goofy ass math humor. Sorry. But you force it. I like that idea of forcing the equation to tell you something. If you plug a 0 in for y, you're forcing it to tell you what the x is in that case. And that's going to be on the x-axis, isn't it? I put a 0 in.
That's the how
Yeah. So 6x minus 5 times 0. There you go. Now it's just plug and chug. Right? Y minus what? What's the y piece? 0. What's m?
Negative 5.
-5/4. That's what we figured out there.
X minus 2.
X minus the x piece. Cool. And I just got to clean that up. Bring this in. Negative times negative is plus. 2 cancels down the 4. The 2, so it'll be 5/2. I know you guys can do that last step. Negative times negative is positive. The 2 cancels the 4 down to 2. That's why it's 5/2 now.
Wait.
You got it? Okay. So that last piece you guys can do. I might have done it in less steps, but you can do it.
Wait.
We're done, right?
That's it? Yeah. That's the equation 1.
And we use that those points in that?
2, 0, 2, 0. I know. Let me ask you this. Here's a lot easier question, right? Can you guys tell me what point does this go through, and what's its slope? Tell me a point that this goes through. Remembering that this is the equation. I love it. Since this is plus 2, it must have been a -2 I put in there for x, right? So it goes through the point -2, comma 7, right? -2, 7. And what's the slope? 4. Because you can see it right there, right? So one thing is, are you able to just read it from, if I give you an equation, can you just read it? If you can't, then obviously you can't do it in reverse. It's even harder. Can you put stuff in the right place? So what point, let me do a little bit easier one. Can anybody tell me what point does that go through for sure?
Point -4.
Give
The point
5, 4, right?
5.
Why aren't the negatives included? Because they're in the equation. What must x1 be? It must be 5.
Yeah.
What must the y piece be? It must be 4. So 5, 4. And what's the slope?
2/3.
2/3. So all I'm saying is, we normally figure this out, don't we? We figure out the slope, we figure out the point, and then we plug it in. See, so it's just a reverse of what I would do. This is when I know everything, so it should be easier. This is when I don't know shit. So of course it's harder, but it's still the same. I'm still just putting them where they're supposed to go. Putting them where they have to go. Yeah.
So the y is never going to be negative?
No, I just haven't given you an example of one. To make the y negative, I just have to put a y plus something here, right? If I had y plus 10 equals -7. Here's it going. What point does this go through? Beautiful. -4, -10. Because this must have been an x minus -4 to make it plus. Do you see that?
Yeah.
So really it's just the opposite sign. -4, -10. And what's the slope?
-7.
-7. I love it.
How come we're switching the negatives and the positives? That's the threw me off with.
All right. Let me ask you this then. Let's take a step back.
Step back. Yeah, help me out. Step back.
No, this is good. Now, that's a little weird, and that's actually a lot in mathematics. It happens a lot where you have to change the sign from what you see. But if I told you something goes to the point 3, 4, let's say -3, 4, and the slope is 2, can you plug things in here correctly? Right? Can you put them in the right place? What goes here?
4.
Well, wait a minute, it's a +4, isn't it? Why is it a -4? Because there's a minus in the equation, right? That's why. So that's not a -4. That is a +4 that I'm subtracting because that's what the equation says.
All right.
M is
2.
2. X minus
Negative.
-3, which of course nobody would leave it like this, would they? The first little thing they would do is make this. So if it's a +3, there must have been a -3 in there. If it's a -4, that must have been just the 4 that I subtracted. Do you guys see that? You don't have to be able to do that as much, but it's funny how that's actually a little bit easier once you get over the whole opposite sign thing. Yeah, good. Oh yeah, sure. I did have a teacher that would write and follow it up with his eraser.
Oh God.
I just couldn't stop doing it. And then you think, it's like, whew. This is, of course, before the days of smartphones, so you have no video taking capabilities.
Right.
All right. Yeah, that.
No, that was one I was writing up. That's a big one.
It's basically it. Point, slow. Same thing down here. Point, slow. Okay.
Yeah, 3.5.
All right.
Oh, no.
Yeah. This is what I've been trying to get to.
After all this, no, it has to be 3.5.
Oh, you'll do okay.
Only do 3.
All right, do me a favor, guys. Let's just try a nice, straightforward problem, because 3-5 is actually, if you've looked at it, it might look really difficult. If you trust me when I say this, but it isn't. So the thing you've got to desperately be able to do is, can you graph that quickly? So do it right now, and then we'll do it together. You shouldn't have to do any tables. You shouldn't have to do any calculations. You should be able to just graph it straight from that. Catch up to you guys. What is the slope of that line? 4, exactly. Mx plus b, right? So the number with the x is the slope always. So that's 4. I can even make it 4 over 1 if I want to, right? What's the y-intercept? 0, -3. I love it. So what do I do first when I want to graph this thing? Beautiful. You have to have a point on your line before you can start moving around with what the slope says, right? So my point on the line, the only one I know is 0, -3. It's right there. And the slope tells me to go where? 1, 2, 3, 4 over 1, right? Positive, both positive. So up and over for positive. I like it. And there's my line. That was damn quick. Those XY tables can take a while. Screw that. They have a much quicker way. Solve for y, bam. You know the slope of y-intercept? Quick. Okay. So what section 3-5 does is it does the same thing. Let me take us back a little bit in time. Recall. On a number line, can you graph x equal to 2? This is going way back in time. Can you just graph x equal to 2 on a number line? What would you do? What would you do? I like it, right? Here you don't have a bracket or anything because it's just a point. So this is one time you're allowed to use that. It's not really a closed circle, it's just a point, right? There it is. So that's really what we just did here, just in 2 dimensions. Oh crap. It sounds science fiction-y, but that's 1 dimension. And this is 2 dimensions, right? What's true? What equals this? All the y's on this line equal to 4x minus 3. So whatever x is, that y is what 4 times it minus 3 would be. That's what this line means. What changes when I say this? What's going to change in my graph? What do I still do the same way, really? I still have to locate 2, don't I? And I know it would be a bracket. Let's go ahead and use a bracket, but it's sort of like in the old days we used to put a point there, right? It's still like a bracket, and then I would shade. And let's overanalyze that for a second. Why do I shade up there? Because does 3 work? Is 3 bigger than or equal to 2?
Yeah.
Yes. Does 1 work? Is 1 bigger than or equal to no? So one side are the answers, and the other side are the not answers. So one way to do this is just pick a point on one of the sides, throw it in. If it doesn't work, shade the other way. If it works, shade that way. Here's the stupid thing. This works the same way. If I do it in 2 dimensions, here we go. So this guy, we're now going to shade one side or the other. On one side are going to be all the answers. On the other side will be the not answers. Right? So here we go. So what have I said? Not y equal 4x minus 3, but y less than or equal to 4x minus 3, let's say. The first step is just like the very first step here is to find that point, isn't it?
Yep.
And we put some symbol on it. I don't care what symbol. We just put a symbol there. So the first step here is to find this line.
Find the slope.
And then we'll shade. We'll figure out how to shade. So that's why I said you better be able to graph y equal mx with b type thing quickly, because now you got more stuff to do after that. Right? That's not the end of the problem. So like we did earlier, here's my -3. And up 4 over 1, right? Here's my line. Let me show you 2 different ways to do this. And one of them is, gets a little weird. My way gets a little weird. It's sometimes not easy to tell what's up and what's down when my line gets really, and then it looks like left and right, not up and down. But one way that always works is called using a test point. Like I said over here, why did we shade that way? Because 3 works. And 1 doesn't work. So of course we're going to shade the way that works. So let's try the point 0, 0. That's the easiest point to try. Because when I plug it in, it's very simple to solve, isn't it? We just see if it works. If that point works, all the answers must be over here. If that point doesn't work, all the answers must be over there. No, for the equal to. Yeah, so I'm going to bring that in a minute. Don't worry. So the test point, you almost always use this as a test point. Any reason I couldn't use that as a test point? Only if my line goes through it. Then it's not on one side or the other. Right? So my line doesn't go through there, so I can use it. When you plug it in, what do you get? 0. 4 times 0 minus 3 is 0 less than or equal to -3. Think about it.
Oh, wait, no.
0 is greater, yeah. So that's not true, is it? So which side are the answers on? That did not work. So I should shade
Lower.
lower. Cool. Right? This should be where the answers are. Really quick, before I go any further, what does that mean about that point? What is that point? 2, 0. Cool. What should be true about that point then, since it's on that side? It should work. Let's try it. If it doesn't work, you guys can go home and forget about this section. All right? Now, of course, it's going to work. 2, 0. What do I throw in for y? So let's check 2, 0. Do you have to actually do this ever in your homework? No. Is it a good idea if you have time? Yeah. So 2, 0. What do I put in for y? 0. Less than or equal to 4 times 2 minus 3 is 0 less than or equal to 8 minus 3.
Yes.
Like,
No.
all right, the same joke twice. I like it. So yes, it does work, right? Of course it will. And any point you pick over here won't work. Any point you pick over there will work. And a real quick, I know in the back of your minds, some of you guys are too polite to ask this question, but it's a great question to ask. Why the hell are we doing this shit? Good question. This kind of thing here is good for when you have restrictions. I always think of like an elevator. You can only have so much weight on the elevator before it will plummet and kill everybody, right? So it's like I have a situation where I have an elevator that can only hold so many people, and I have to get, what do I want to say? I'm thinking about a situation where I have several restrictions on what I'm trying to do. So the elevator can only hold so many people. What else do I want to say? The door will only let so many people through, whatever. And I'm trying to figure out where's my area that's safe. So any situation, if you're on a construction site, you use this kind of thing all the time. The building can only have so much force this way and that way. So you can kind of figure out, where's my safe zone? What can I use safely, right? So that's the kind of problem this thing works beautifully for, is several restrictions. So thankfully for right now, we're only graphing one of these lines at a time. In real life, very often you get several of those things at one time to see where you should be. I know you guys are getting a little bleary-eyed. We're going to do another problem. We can either take a break, or I want to do something out of the chapter 4, and then we're going to go home after that. So it's up to you guys.
Let's just knock it out, huh?
That's my vote, but
Let's get out early.
you know,
Let's knock it
why-
out.
All right, here we go. So let's try this one here.
Is this on 4?
So is this still section 3.5?
We're still on 3.1.
Let's make this, yeah, that's one. Yeah, the difference here, what's the main difference between these two that have a lot to do with these inequalities and shading and stuff? This one was less than or equal to. That fraction is only slope, right? So that fraction doesn't even bother me because each piece means something. So it's not really even truly a fraction, it's just 1 up, 2 over. Here it's allowed to equal. So somebody asked earlier, this is a solid line, much like you'd have a closed circle from way back when. In this case, you'd have an open circle. Now, how to do an open circle line? We do a dotted line. Dotted line is the same thing as an open circle. It means don't include these points because they don't work. Right? I can't include the points on the line because it's supposed to be greater than that line. So first thing I want you to do is try to graph that line. Don't forget to make it dotted. Boom, boom, boom. And see if you can figure out which side to shade. Could be. I forgot about the second way, which is that.
Are we going to be doing like 2 inequalities?
Yeah, that'll be in chapter 4, the last section of 4. This 4 is all about systems of equations. We have more than one thing going on. Yeah. All right, guys. So graphing this line should be the quick part. Right? -3, intercept, and up 1 over 2. I like it. And then you have a dotted line. Hopefully yours is more straight than mine. And if you want to use a test point, 0, 0 is 0 bigger than 1/2 times 0 minus 3. Is 0 bigger than -3? Yes. So I'd shade this way. The other method is greater than you shade up, less than you shade down. But my point is that gets a little confusing, especially when the slope gets big.
Right.
Then what the hell's up and down? So I understand why people don't like that sometimes. You always have the test point to help you out. But it really is that simple. Greater than, shade up. Less than, shade down.
So what is it when it's that far?
Same thing. You'll always have a bit of a lean some way. So this is up and that's down. Right? So it really is. People still have trouble with that. Yeah. You guys see that? Real quick, what would that point, what would be special about that point? Except for the fact that he would not make that work, right? And of course, that point would make it work. That's the whole point. Okay, cool.
So if you use 0, 0, that's fine. You can't use it, right?
As long as the line doesn't go through it. And what I do is if my line goes through 0, 0, I use 0, 1 or 1, 0. The next easiest one, right?
Why do you shape it that way?
2 reasons. One is like this y. Where are the y's bigger than that? Aren't they up here?
Yeah.
Another thing is 0, 0. If that works, that must be where the answers are. If it doesn't work, the answers must be on the other side, right? In my head, I always think Giants fans and Jets fans. You got a Giants fan. This all the Giants fans over there, so they don't kill the Jets fans. They've got it in the wrong place, right? If you don't like football, you didn't get that at all.
Not at all.
So 0, 0. If you plug it 0, 0 in, it comes out to be a true statement. So that must be where all the answers are, in the direction of 0, 0. If it doesn't work, it must be the other side. It really is that simple, and it's exactly the same thing we do in one dimension. It was even easier than that in one dimension, but that's really what's going on. Shade one way, don't shade the other. Yeah.
So only just with 0, 0, and that's it? I mean,
As long as it doesn't go through the line. So let's do one that goes through 0, 0. Let's do negative 3 halves x. Let's do that. So y less than negative 3 halves x. So here's a freaky thing. What's my y-intercept?
0, 0.
I like it, 0, 0. It's 0 because there's nothing. It must be plus 0 because that wouldn't show up. Oops. So 0 is my y-intercept. Where do I go from there? Down 3. Over 2. What kind of line? Yeah, dotted. Now if you want to do a test point, you cannot use 0, 0. It wouldn't tell you. You plug 0, 0 and it's going to be 0 less than 0. That's not going to tell you anything. So I can use 0, 1. So if I put a 1 in for y, is that less than negative 3 halves times 0? Is 1 less than 0? Is 1 less than 0? No. So then you wouldn't shade that way. You'd shade the other way. And look again. Which way does it say? Less than. That would be down. So both ways have to agree. It's in kind of if you understand both ways, you can use both ways. They have to agree. So hopefully. So really, it's just drawing a line. The only new thing is shade one side or the other. You got a 50-50 chance of doing it. No. I like that. I don't know if anybody ever thinks that way. I'm sure they do.
What if it's vertical? What if it's on the y-axis?
Oh, then you have your special cases. You have like, let's see what you guys think about this here. X greater than or equal to negative 1. Now, I'd have to say, graph this on an XY plane or graph this on a coordinate system, right? Because if I just said graph this, you would just do a number line. I wouldn't blame you. But I want you to graph it in 2 dimensions. How do you graph x equals negative 1? Who remembers what kind of line that is? Careful, it's not that way, it's that way. So negative 1, it'd be this. And then what kind of line will it be? Solid. And where the greater, special cases are actually easier for shading, greater.
Get it that way.
Yeah, cool. I like it. So y would just be this and then up or down.
Yeah.
Right? So the special cases are easier unless you try to force them into not being a special case. Then you go, what the hell? But they are easy.
Because x is greater than or
I don't know if you guys remember I said whatever letter's missing, it's going to be parallel to that axis. I don't know if that helps anybody. Y is missing, it's going to be parallel to y. If x is missing, it'd be parallel to x. Okay. All right. Okay. So as I promised, we're only going to do a little bit out of 4. Then we're going to head out. Just to remind you guys, a week from this Wednesday, we have a test. So on Wednesday, I'll have the practice test. Right? Next Monday, will be review. Oh, yeah. Seems like just yesterday we had the last test, but it's actually been a couple weeks. Yeah.
I'm sorry, say again your thoughts on that.
I did. So next Wednesday, a week from this Wednesday is a test, like it says on the homework sheet. This Wednesday I'll have the practice test. It'll only go over as much of Chapter 4 as you make it through by next time, right? By this Wednesday, right? Just like the last test didn't quite make it all the way through Chapter 2, so we didn't have 2.8 on the test. Same thing this time.
We haven't gotten into 4 yet.
So whatever we get to 4 today.
No, whatever we get through on 4 on Wednesday will be as far as the test goes. Okay, so here we go. We're going to get a little bit into 4 right now. Stay with me now. I don't say do this a lot, but I desperately needed this myself. I'll pay for it later, but I don't care.